Okay, let's start dealing with problem 11. A square of area 2 is inscribed in a square of area 3, creating four congruent triangles. Just for our non-native test takers, congruent means similar, they're the same. And by these four, it means like these four triangles that you see over here. It's just saying that all of them are the same and similar. Okay, as shown below. What is the ratio of the shorter leg, which is going to be this part, to the corner leg of this one shaded area? So we just want to find these two, okay, the ratio of these two, okay? So so let's focus on this red side. What is this red side? If I told you we have a square and the area of the square is 4, you would just go, okay, square root of 4 is 2. So you would just say, okay, the side is 2 and the side is 2. Okay, so the same principle. The big area is 3. So the side of that will be a square root of 3. And the blue one will be a square root of 2. Okay. So in this case, what do? We just have to write an equation. Okay. So because it said that all of these are congruent, that means this part, this part, this part, and this part are all equal. So let's just give them a new name. So I'm going to assume this part will be A. Okay. So the red one, okay, the red side over here from here to here will be a square root of 3 minus A. Okay, so I'm going to write it here. Okay, all of it is square root of 3. This will be a square root of minus 3. And you would see that this short side is again, okay, this one, the square root of 2. So we just have to write the Pythagorean formula for this right triangle, okay? So it's going to be a square root of 3 minus A is squared plus A is squared, this one, will be the square root of 2 squared. Okay, so all we really need to do is just to expand this one. Okay, now let's expand the first expression. It will be 3 plus A squared minus 2 square root of 3A. Okay, plus this one. A squared and the square root of 2 squared will be 2. Okay, so let me just write it. So we just have to deal with this quadratic equation. It's going to be like 2A squared minus 2 square root of 3A. Okay, plus 1 is equal to 0. Okay, let's continue like this. So I'm just going to use the quadratic formula. Okay, so it's going to be minus this one. It's going to be positive 2 square root of 3 plus minus square root of this one is squared will be 12 minus 8. Okay, divided by 2 times of this, which is going to be 4. Okay, so this, the value of this is going to be 4. Square root of 4 is going to be 2. So when I simplify it, so the value of A will be, okay, square root of 3 plus minus, okay, 1 divided by 2. Okay, so now the question we need to ask ourselves, which is possible for this one to be true? We just want the value of A. Will it be the positive one or the negative one? Okay, now because we selected A as the smaller part, so I'm going to continue with the negative one. Okay, you could also continue with the positive one, still will be correct. So if this is the value of A, now we want the value of this part. Okay, it would be the larger side of the triangle, the larger leg. So all I have to do is just write this one. All of this, the red one, was a square root of 3 minus the value of this. Okay. So this value will be 2 square root of 3 minus the square root of 3 plus 1 divided by 2. Okay, so you will see that the larger leg will be a square root of 3 plus 1 over 2. Okay, so we want the larger one, which is this one. Okay, this would be the larger leg. Okay, this would be the smaller one. So we just need to find the ratio of these. Let me do some cleaning. Now the question is looking for the ratio of the smaller leg over the larger leg. Okay, so as you see that the square roots of these two will cancel. So what we're going to have is the square root of 3 minus 1 square root of 3 plus 1. Okay, and this is not either of the options. So what we really have to do here is multiply both of them by square root of 3 minus 1, square root of 3 minus 1. Okay, so you know that this is actually just 1. We're not changing the fraction. So what happens here? This one will be the square root of 3 squared, okay, minus 1 squared. Okay, so it will be 3 minus 1, which will be 2. Okay, so this one will be a square root of 3 squared minus 2 square root of 3. Okay, plus 1. So what we're really going to have is going to be like 4 minus 2 square root of 3 divided by 2. And finally, you would see 2 minus the square root of 3. So this would be the final one. You don't have to go, you don't have to write whatever I wrote here. So the reason I just expanded so much and explained so much so that if you are confused at any part, maybe this will help you. Okay, let's deal with problem 12. I don't think it's really that difficult. How many 3-digit positive integers n satisfy the following properties? The number n is divisible by 7, okay? And the number 4, by reversing the digits of n, is divisible by 5, okay? So let's just write a number. So for example, I'm just going to write a 3-digit random number, okay? So if I reverse this one, it becomes 411. Is 411 divisible by 5? No. Okay. So this digit is becoming this digit. Okay. If I want this one to be divisible by 5, this one has to be either 0 or either 5. Okay. So this one can either be 0 or 5. But if it's 0, it's going to be a 2-digit number. So we're not going to accept this. So this should be 5. So what does that mean? That means all our numbers should start with 500. Okay. So we have to find the numbers that start with 5. Okay. That are between these two, 599, that are divisible by 7. Okay. So we just, this is a simple counting question. What is the first numbers like that? So we know that 490, right? 49 and 7 is squared, is divisible by 7. So 497 is, okay, plus another 7 will be 504. So the first number that is divisible by 7 is 504. The next one will be 511. Okay, the next one will be 518. Okay, so you could write down all the numbers, or you could do something like this. Okay, so the first number is 504, and we just want to multiply everything by 7. Okay, so, and this one still has to be less than 600. Okay, so if you try that, K13 will work. Okay, so it's going to be like 504 plus 13 times 7, okay, which would be 595. Okay, so, but we have to be really, really careful here. Will the answer be 13 or not? Okay, so remember, the first one, if you put k here, okay, if k is 0, it would be our first number. Okay, so you really are counting these numbers from 0, 1, 2, 3, and all the way to 13. Okay, so don't forget this 0. Okay, because if you forget that one, you're going to select 13, which is going to be wrong. So you have to include this one. So it will be like 14 numbers. Problem 13, A and C are standing 48 feet apart in a field. Okay, so I'm going to draw it like this. Instead of Abdul, I'm going to write just A, and this will be our C instead of Chiang. So B is standing in the same field as far from A, okay, as possible, so that the angle formed by his lines of sight to Abdul and Chiang measures 60 degrees. So we have this person B, okay, and the eyesight will be, so for example, if the B looks at C this way and B looks at A this way, it will create an angle. Now here it says that this angle should be, okay, 60 degrees, okay? So we just have to realize where actually B is supposed to be, okay? Because it says we want it to be as far away as A. So you see, now if we put B this way, right, the angle would be really sharp, right? This would not be a 60-degree angle, okay? So as you come closer to A, this angle starts to increase and gets larger. And when this is 90 degrees, okay, so this would be the angle that we're looking for. So now if we suppose B is here, okay, because here it says 60 degrees, so here we'll have like 30 degrees, okay? So we know that the distance between A and C is 48 apart, okay? Now here, because AB is the hypotenuse, I'm going to call it hypotenuse, okay? So the line opposite of this 30-degree angle, we know is going to be half of H, okay? So let's just find it. So I'm going to just write a very simple equation. Let me just clean this one first. Okay, so we're going to get H over 2 squared plus 48 squared is equal to H squared, okay? So I will just expand this. It will be 48 squared will be equal to 3 over 4H squared. Okay, so to find, the question was only, okay, H squared, so the answer will be equal to 48 times 48 times 4 and divided by 3. So once you do that, the answer will be 3072. Okay. Not a difficult one, right? Okay, problem 14. I think this one is all about understanding it. If we understand the question, I think it's very easy to get it right. A number is chosen at random from among the first 100 positive integers. Okay, it's going to be like 1 to 100. We're going to select one random number. And a positive integer divisor of that number is then chosen at random. Okay, like for example, imagine I pick 87. Okay. So what are divisors of 87, right? It could be 1. Okay. It could be 3, right? So what could be 87, right? It's just, we select one of them again, one of the divisors. What is the probability that the chosen divisor is divisible by 11? So for example, in this case, what is the chance that the number that we chose here is 11? So for example, if we choose 87, 11 is not a divisor of this. So there's no chance. Okay. So we have 100 numbers, right? So let me just go right. If the first number that we choose is 1, right? Is 11 divisor of this? No. So what is the chance of that happening? 0. Okay, 0. What if we choose 2? 2. Is 11 a divisor of this? No. Again, 0. So you would see that we just have to write 0 plus 0 plus 0. And the first number that we have to deal with is 11. Now, if the first number we choose is 11, 11 has only 2 divisors, okay? Either 1 or either 11. What is the probability that the chosen divisor is divisible by 11? If you choose 1, no. If you choose 11, yes. So it's going to be 1 over 2. And then it will just for 12, 0, for 13, 0, for 14, 0, until we get to 22. Okay. So what are the divisors of 22? It's going to be maybe 1, maybe 2, maybe 11, maybe 22. How many divisors do we have? 4. How many of them are divisible by 11? 2. 2 over 4 is again the same as 1 over 2. So let's do that for 33. It's going to be exactly the same thing because it's going to have 1, 3, 11, and 33. So let's just check 44 because 44 will have more factors. It could be like either 1, 2, okay, 4, 11, 22, and 44. Again, it will be 3 over 6. So it's going to continue, right? For 33, 44, 55, 66. And the first one was 11. The last one is 99. So how many of 1 over 2's do we have like this? 9, okay? So it will be 9 times 1 over 2 divided by 100. So this would be equal to 9 over 200, right? Not a difficult one, was it? Okay, this problem has the potential to waste a lot of your time and kill the test for you. So let's just read and understand it first. An even number of circles are nested, starting with radius of 1. So this one, radius of 1. What is the area of this? Pi 1 squared. The area of this will be pi. Okay. And increasing by 1 each time. So for example, this one, the radius of the one, this here, from here, this will be 2. So the area of this one will be 4 pi. Okay. So let's just read it here. All sharing a common point. The region between every other circle is shaded, starting with the region inside the circle of radius 2, but outside the circle of radius 1. Okay, so for example, if we only have 2 circles, okay, so the big circle would be like 4 pi. The small one will be minus 1 pi. Okay, so if we take out pi, it's going to be pi 4 minus 1, which is going to be like 3. Okay, so let's continue this. And an example showing 8 circles is displayed below. What is the least number of circles needed to make a total of shaded area? Okay, so let's just deal with the next one. Imagine we only have 4 instead of 2. So it would be this big circle. Okay, the radius of this will be, this is 2 here, this will be 4. So this one will be 16 pi the one that is inside it, okay? So from here, it was 1, 2, 3. It would be here. It would be 3 here. So minus 9 pi. Okay. So again, if we take out pi, it will be 16 minus 9. Okay. Okay. Now, as these circles continue, these numbers will also continue. But one thing, you see that now the final result has pi. These have pi's. So this pi will be canceled by all the pi's that we're going to add. So I'm not going to just write them. I'm going to ignore writing them. Okay. So the first one, okay, will be, I'm going to write it like this, 2 squared minus 1 squared. Okay, for the first two circles. For the next two, as we had it here, it will be 4 squared minus 3 squared. And let's continue. It will be 6 squared minus 5 squared. And this will continue. And the last one, okay, which is going to be an even number, is going to be n squared minus n minus 1 squared. This will be odd. And this has to be larger than 2023. Okay, this is the part that could waste a lot of your time. Okay. So let me just write it this way. I'm going to clean this part. Okay. So this part, oh look, we could write it as 2 plus 1, okay, times 2 minus 1, which is 1, right? So why bother? I'm going to write it like this one. So these two are equal to 1 plus 2. Now these two are again equal to 4 plus 3 times 4 minus 3. So 4 minus 3 is 1. Why bother writing it? So you could see something beautiful, right? The first two are 1 plus 2. These are equal to 3 plus 4. So let me just write them like this. This will be 1 plus 2. So this will be plus 3 plus 4. So the difference of these two, okay, will be 11, which is equal to 5 plus 6. Okay, and this will continue all the way, okay? So it will be n minus 1 plus n with the same reasoning. Okay, this has to be larger than, okay, 2023, okay? Now everything looks a lot simpler, okay? So all we really have to do is just write it this way. Okay, we know that the last one, 1 plus n, okay, divided by, okay, n over 2 is supposed to be larger than 2023, okay? So we know that 1 plus n times n is supposed to be larger than 4046, okay? So which number would do that? We want the smallest number that will do this. So now at this point, if we try 60 instead of n, it will be 60 times 61, okay, which will be 3660, which is not going to be large enough. So definitely the answer will be E64 times 65, okay? Okay, problem 16. In a table tennis tournament, every participant played every other participant exactly once. Although there were twice as many right-handed players as left-handed players, we're not going to use this piece of information. We don't need to. The number of games won by the left-handed player. So I'm going to write it like this. The number of games that were won by the left-handed players, okay, was 40% more than the number of games won by the right-handed players, okay? So there were no ties and no person who could use both of their hands. What is the total of number of games played? Okay, so they're playing, right? Either a person with left-handed wins or either a player with right hand wins. Even if like two right-handed players play, okay, a right-handed player will win. So that would be like all the games, okay? So it's gonna be like all the games, okay? Let me write. So now here it says that this one, the left-handed, is 40% more. So my question to you is, can this number be any integer? So for example, can this one be 11? Okay, if we add 40% to 11, will that be an integer? The answer is no, it will not be an integer. Okay, so that would limit the number of options that we have. Okay, so let's apply that. So here it says 40%. We know that if you add 40% to 100%, it's going to be like this, 140 over 100. Divide both of them by 100 is going to be 1.4. So I'm going to write it this way. Okay, so 1.4 of GR, okay, instead of the games won by the left-handed people, okay, plus G, the games won by the right-handed people, will be all the games. It will be one of the numbers here, okay? So if I factorize, okay, GR, it will be 2.4. My pen is not writing. So it will be 2.4 of GR, which is going to be the games won by the right-handed people. It has to be an integer. When you multiply it, this again has to be an integer. That means which of these number we divided by 2.4 still would be an integer. Okay, so when you do this, this will be out, this will be out, and this will be out. These are the only two numbers that are possible for the total number of games. Okay, so now here, how many participants are allowed to be there? Imagine you only have two participants, A and B. How many games? One game. Okay, if we have three participants, A would play with B, A play with C, 2, and B and C play together. So it would be 1 plus 2. If I add another player here, A would play with all the three. Okay, so it will be 3 plus, okay. And then B will play with these two, plus 2, okay. And then C and D play. So you would now pay attention to one thing. When we have 4 participants, it's going to be 1 plus 2 plus 3, not plus 4. Okay, this 4 is missing. Okay, so if we have n players, it's going to be 1 plus 2 plus 3 all the way plus n minus 1. Okay, so what would be the general formula for this? Okay, it will be n multiplied by n minus 1 divided by 2. Okay, so now which one will follow this formula? Okay, so for example, if we have 9 for n, if we have 9 participants, it will be 9 times 8 divided by 2, which is going to be 36. This one is okay. Okay, if we have 10, okay, it will be 45, but this already out. So if we have 11, look, if we have 10 players, it will be 45. If you have 11 players, there will be 55. So there is no way there could be 48 games played, right? So that would just make 48 out. So the only option left would be option B over here.